Hello guys. Okay, turn to page 476 of problem 9.22, and for this case you are given a coaxial capacitor with length of L 40 centimeter, and then it has an inner radius of A equal to 1.2 centimeter, and also for the outer radius, which is 4 centimeter. And then for these types of dielectric in between, in these regions, it has the homogeneous permittivity given as 10 power of minus 11 farad per meter, and also it has the conductivity value of 5.8 times 10 power of 7 Siemens per meter. And then we are given straight away the E field that actually propagate within this coaxial capacitor, as shown here, 10 power of 6 over R cos 10 power of 5 time, all right, in all directions. Okay, so now we are going to find the conduction current density, conduction current, as well as displacement current. All right, so as we learned last time, we can simply find the conduction current density by applying this formula. The JC is equal to the sigma E. Right, so since sigma is given as shown here, so just substitute the value of sigma. Gonna have here 5.8 power times of 7, and then times with 10 power of 6 over R cos 10 power of 5 T in R component. So lastly, gonna have the JC expressions as 5.8 times 10 power of 13 over R cos 10 power of 5 T in R component, and it has a unit of ampere per meter squared because it's current density. Okay guys, so that's our conduction current density, and now we are going to calculate the conduction current, the IC, which can be obtained from the JC itself. So as we learned last time, the IC, which is the conduction current, can be obtained by integrating the JC over the DS. So integrate the JC dot DS, and now since we know that the JC here actually propagate in all directions, so by right the DS also must be in all directions. So recall our last lecture on cylindrical system coordinate, whereby we can find the DS in R, which is R dv dz, right? So let's substitute the value. Now we have integrations 5.x times 10 power of 13 over R cos 10 power of 5 T in R directions, and now the DS again must be in R directions to make it valid. Now we have here the R dv dz. Okay guys, so now you can simply delete this R down here, the up there, and also we can just set the limit of each variable, the dz, let's say from 0 to L, let's set there, and then the phi, since a full circular, so we have 0 to 2 pi. So now you can have simply the IC, which is 5.8 times 10 power of 13, then just multiply with the dv here, 2 pi, and then the L is 40 cm, and then the rest of term cos 10 power of 5 T ampere. So if proceed, you're gonna have this value 4.64 pi times 10 power of 13 cos 10 power of 5 t ampere. Okay guys, so that's our conduction current. And then lastly, we are going to calculate the displacement current. So we know that the ID, displacement current, can be obtained using the same step as shown previously, which is integrate the JD dot ds, whereby guys the JD here actually our displacement current density can be obtained using this step, which is d over dt. And then guys, we know that the d actually equal to epsilon E. Okay, so let's find the d first. The d, which is our electric field density. So the d here actually 10 power of minus 11, the epsilon as given here, and then times the E, which is 10 power of 6 over R cos 10 power of 5 T. Alright, and then unit of coulomb per meter squared, and then it should be also in R component. Okay, alright guys, so that's our d. So now let's differentiate the dt, the d over t, to find the jd. So now I have to find the jd. So now I have a negative 10 minus 11, 10 power of 6, and then differentiate the cos, gonna have negative sign, and this bring in front, so 10 of 5 sine 10 power of 5 t R component and over R. Okay guys, you're gonna have finally your JD is equal to the negative sine 10 power of 5 t over R in R component, again unit of ampere per meter squared. Alright, so let's proceed the next part to find the ID, which is your displacement current, and just integrate the JD.ds. So now I'm gonna have here these expressions, negative sine 10 power of 5 t in R component over R, and again here ds must be in R, so you have R dv dz. So you can simply delete this R down here, this R up there, and you can proceed whereby you're gonna have this value of negative 2.513 sine 10 power of 5 t ampere. Yes, so the limit here, we know that from 0 to L, and also the phi from 0 to 2 pi. Okay guys, that's our ID. Okay, so I hope you can try yourself, and all the best for your study. Thank you.